Assalamu alaikum, brothers and sisters. Welcome to the journey of quest, where we quench your thirst of knowledge. Ever pondered how the vast ocean and the invisible atmosphere interact? It's a question that might not frequently cross your mind, yet the answer shapes our world in profound ways. Welcome to the intricate dance of Earth systems, a spectacle of nature that choreographs our weather, our climate, and indeed, our very lives. To understand this dance, let's first meet the dancers, the ocean and the atmosphere. They are not separate entities, but rather partners in an intricate ballet, each influencing and being influenced by the other. They are intertwined in a delicate balance, a dance that sustains life as we know it. Now, imagine the ocean as a vast blue sponge. It absorbs a considerable amount of heat and carbon dioxide from the atmosphere. This absorption is critical, for without it, our planet would be unbearably hot and our air unbreathable. But the ocean isn't just a passive participant in this dance, it gives back too. Picture the ocean as a colossal natural humidifier, releasing moisture into the atmosphere. This moisture forms the clouds that bring us rain and snow. The ocean also releases heat, which drives weather patterns and impacts climates around the globe. The atmosphere, for its part, is far from a silent partner. It takes from the ocean and gives back in a continual exchange. It absorbs moisture and heat from the ocean, and in turn, influences ocean currents and temperatures with its winds. This dance, this exchange, is constant and ongoing. It's a perfect example of nature's balance, a delicate equilibrium that has evolved over billions of years. It's a dance that we're only beginning to fully understand, yet its impact is felt every day, in every corner of our planet. So, the ocean and atmosphere, far from being independent entities, are more like dance partners, each responding to the other's moves. It's an intricate dance, one that we are all a part of, whether we realize it or not. But what if there was a puppet master, subtly controlling this dance? Now, let's dive deep into the Pacific Ocean and meet the Niño-Southern Oscillation, or ENSO for short. This isn't an underwater creature, but a recurring climate pattern that plays a significant role in the temperature of waters in the central and eastern tropical Pacific Ocean. Imagine ENSO as a conductor, orchestrating the performance of the ocean and atmosphere. During normal conditions, trade winds blow across the Pacific, pushing warm surface waters towards the western Pacific. This allows cooler water to rise to the surface in the east, but every 2 to 7 years, these winds weaken or even reverse, causing the surface water to warm. And this is where ENSO steps in, disrupting this rhythm and leading to significant changes in weather patterns worldwide. You see, the dance between the ocean and atmosphere is delicate. A slight change in one can cause a ripple effect, altering the other. ENSO, with its ability to change the temperature of the Pacific waters, can instigate these alterations. It's like a domino effect, with one tile setting off a chain of reactions. When ENSO comes into play, it can cause the trade winds to weaken, allowing warm water to spread across the Pacific. This disrupts the normal patterns of wind and rainfall, leading to an increase in sea surface temperatures, a phenomenon known as El Niño. But that's not all. ENSO can also cause the opposite effect, strengthening the trade winds and leading to cooler than normal sea surface temperatures, a phenomenon known as La Niña. But why does this matter to us? Because these changes can lead to significant weather changes worldwide. From torrential rains and flooding in some regions to severe drought in others, ENSO's influence reaches far beyond the Pacific. So ENSO, this seemingly distant phenomenon, can influence weather and climate patterns globally, making it a key player in our planet's climate system. It's the puppet master, subtly controlling the intricate dance of Earth's systems. Like a coin, ENSO has two sides, El Niño and La Niña. But what are they? Picture a pendulum swinging back and forth, each swing representing a shift in the climate system. This is the dance of El Niño and La Niña, the two extremes of the ENSO cycle. Let's start with El Niño. Imagine you're by the Pacific Ocean. Suddenly, the ocean's surface begins to warm up, like a heated swimming pool. This is no ordinary warmth, though. It's a significant increase in temperature that can last for several months. This warming alters the usual east-to-west winds, flipping the script and causing them to blow in the opposite direction. As a result, weather patterns across the globe are thrown into disarray. Droughts may strike where rain is usually plentiful, and floods may occur where it's typically dry. Now, let's swing the pendulum to the other side. Enter La Niña. Picture the same Pacific Ocean, but this time it's cooling down, like a refreshing iced drink on a hot summer day. This cooling, much like El Niño's warming, is not a minor shift. It's a marked decrease that can persist for months. This temperature drop affects the winds too, blowing them stronger than usual from east to west. And just like its counterpart, La Niña doesn't play nice with global weather patterns. Places that are usually dry might receive more rain, while those accustomed to precipitation might find themselves in a drought. But why should we care about these changes? Well, they affect everything from agriculture to wildlife, from water resources to even our health. They are so influential that they can cause billion-dollar weather disasters. So, El Niño and La Niña, the twin faces of ENSO, are vital cogs in the wheel of Earth's climate. They reflect the Earth's ever-changing dynamic nature and remind us of the intricate dance of systems that sustain life on our planet. But how does ENSO's dance with the ocean and atmosphere affect us, the inhabitants of Earth? Well, let's dive into it, shall we? The El Nino Southern Oscillation, or ENSO, is more than just a weather phenomenon. It's a global conductor, orchestrating a symphony of climatic variations that ripple across our planet. When ENSO swings into its El Niño phase, it can stir up some pretty dramatic changes. Picture this. A warmer Pacific Ocean can trigger violent storms along the western coasts of the Americas, while potentially causing droughts in places like Australia, Indonesia, and even southern Africa. On the flip side, when ENSO transitions into its La Niña phase, the pendulum swings the other way. Cooler Pacific waters can lead to drier conditions in South America, but may also result in heavier rainfall in Southeast Asia and Australia. These shifts in weather patterns can bring about floods, wildfires, and other extreme weather events, all of which can have profound impacts on the world we live in. But it's not just about weather. These climatic changes can disrupt agriculture, throwing food production into chaos. Imagine farmers facing unpredictable seasons, struggling to grow crops amidst the capricious whims of nature. It's a daunting prospect, isn't it? And let's not forget our wildlife. Animals, too, feel the brunt of these changes. Migratory patterns can be disrupted, food sources can dwindle, and habitats can be destroyed. It's a domino effect, where one change triggers another, and another, and another. And then there's the economic impact. Extreme weather events can lead to costly damages and recovery efforts. Economies, particularly those heavily reliant on agriculture and fishing, can be hit hard. Tourism can suffer. The ripple effects of ENSO are felt in the pockets of everyday people, from farmers to fishers to business owners. So, ENSO's influence extends far beyond the Pacific, shaping weather and climate across the globe, and in turn, our lives. It's a powerful reminder of how interconnected we all are, and how the dance of the Earth's systems can touch every corner of our world. As our planet warms, what could become of ENSO and its global impacts? Current scientific research suggests that climate change could potentially intensify the effects of El Niño and La Niña events. With rising temperatures, we might see more frequent and severe weather patterns, from droughts to floods, affecting communities worldwide. But the complexity of these coupled ocean-atmosphere systems makes predictions challenging. The interplay between the seas, the skies, and the warming planet is a dance of such intricacy that even the most advanced models struggle to capture its full scope. This highlights the crucial need for continued research. By deepening our understanding of ENSO and its interactions with climate change, we can improve our predictions and better prepare for future impacts. We can develop strategies to mitigate damage, protect vulnerable populations, and safeguard our planet's health. While we may not have all the answers yet, one thing is clear: understanding ENSO and the ocean atmosphere system is key to predicting our planet's future. Thanks for watching us share our videos, subscribe our YouTube channel, and press the bell icon and stay curious for new uploads.